voltage is applied to an inductor of 1 Henry. Find the steady state current through the inductor. Voltage is given. Can you find current? Again, let me do this. The complex number corresponding to this is, notice 12. We don't worry about omega. We don't worry about time. We only worry about amplitude and phase. Okay, this is the voltage phasor. Okay, this implies ZL equals J omega L. Can we actually again write this as a complex number? We know omega. Okay, we know L. Okay, this is J into 60 into L is, notice 1 Henry. So this is 60 J. Okay, we want the current vector. This is just V by R, or what plays a role of that is impedance Z. Take the voltage vector divided by impedance, you get the current vector, current phasor. That is 12 at an angle of 45 degrees. Can we also write this as in angle notation for doing the math? 60J. 60J is a complex number. What is the magnitude of it? What is the phase of that complex number? We did this a few minutes back in the primer. We can go from x plus iy to r angle phi, or r angle phi to x plus iy. What is angle of complex number J? Simple, right? The real part is 0. That is along the imaginary axis.
90 degrees. Angle will be 90 degrees.
This is 60 angle 90 degrees. Thank you very much for that. Okay, so notice this is going to be 12 by 45, 60 by 90 degrees. Okay, thank you. So notice, so this is 12 by 60, that is 12 divided by 60, 0.2. What happens to the angles? Angles get cancelled, subtracted, right? 45 degree minus 90 degrees. That's a total angle. That is essentially 0.2 at an angle of minus 45 degrees. And we could also kind of see that, there is a phase difference between voltage and current at the end of the day is 90 degrees. This is plus 45 degrees. So current actually is, leading voltage by 90 degrees. And let's also write, give this in an actual function form. This is in phasor form. It's actually 0.2 cos of 60t plus, or actually not plus, it's minus 45 degree. That's it. You got the answer just by applying V is IR. There is something like, resistance even for AC circuits. If you're looking at one particular frequency, you can write V is IR relation and get, answers easily. And this is a simple example, just, one inductor, that's it. We are not even talking about a network yet, but all the principles apply. Again, if you want some clarity on that, let's remember these numbers. Okay, so this is our current, this is V of t, our I of t is 0.2 cos of 60t minus 45 degrees, right? As a phasor, okay, let me take one step back, sir. I know inductor is, yes, 90 degrees different from this. So let me find the magnitude of ZL, right? Yeah, you could do that. Point is, it won't work if you have, Z is a combination of capacitor and inductor. If you have combination of capacitor and inductor, this is a way to do, right? There, the phase degree can be any number between 0 to 90 degree, or in fact outside of that also, based on what the complex number is, what the combination is. In this case, yes, you can directly write it down. In fact, now We will start. I have slightly, of course, non-trivial example. Okay, resistor and a capacitor, simple combination. Okay, so notice voltage is, this is our cos, right? Voltage vector here, it has, this is 12 at an angle of 45 degrees. Okay, current vector is 0.2. It's actually a small vector at an angle of minus 45 degrees. So it's an inductor. Notice civil, that simple mnemonic. Voltage is leading current. And if you, again, if you are, this, we'll repeat this once for clarity. Okay, quickly, what is this curve? Notice is slightly advanced by 45 degree. Okay, so this is the cos curve we are looking at. At initial at t equals 0, it's cos 45 degrees. Okay, let's say, and this peak is 12. This is v of t. Okay, this peak is 12, and the current I of t. Okay, the units are different. It's 0.2 peak, and where does it start? It has like it is with respect to this, it has a minus 90 degree phase. Yeah, voltage started here. Voltage curve is this. I'm exactly drawing the top curve. With respect to that, current is ahead of 90 degrees. Okay, so roughly this is 90 degree. So this curve, instead of starting here, it is actually starting here. This is our I of t, and this peak is 0.2. Notice some function, some sinusoid function of time. Okay, this instantaneous is a complicated relation. But if we look at the phasor, okay, this is a voltage phasor, this is a current phasor. And as the voltage phasor moves, the current phasor follows. So as the voltage phasor moves, current phasor follows. And what makes our life easy is this. In phasor presentation, this Z, the impedance, makes our life easy because it just plays a role of resistance. If you know complex number division, you are done with this. Multiplication, division, you are done with this. And which is also why we looked at it at the beginning of the class. What is A plus bj by c plus dj? How do you divide two complex numbers? The reason to look at it is, we want to know how to divide by impedance and all that. Let's look at one more example.